Right, so we'll start this first lecture now. So my name is Gaurav Bhutani. I'll be teaching this course called High Performance Scientific Computing. This is the second time we are teaching this course in the institute. It's called ME 522. Now it's called an ME code, but the course is more general. In fact, last time we had a good mix of students from different departments, and I'm sure this time also. How many people are there from mechanical? Quick raise of hands. Okay, civil, electrical, computer science, bioscience, engineering physics, data science. What is left? Material science. Yeah, no, but that's very new. And let's go to postgraduates. How many PhD students are there? PhDs? How many masters? Okay. How many masters in mathematics, MSc maths, MSc chemistry, MSc bio, MSc physics? Good. So we have a good mix of students in the class. I think this is one of the most heterogeneous class we have had, and that's the course. What the course is about, heterogeneous computing. Okay. Uh, so as I said, I am based in mechanical engineering, but I'll be teaching the course in such a way so that this can be understood by a wide spectrum of people, as long as you understand computing, because this is what the course is about. Uh, my background wise, I work in a field called fluid mechanics, which has a lot of overlap with mechanical engineering, physics, computer science, as well as a lot of high performance computing and applied mathematics as well. So that's the reason we are going to teach you this course, given a background in fluid mechanics. So this course will cover topics which include topics ranging from, I'll be going through a detailed list of lectures soon, but we'll be talking about programming languages, starting from more prototyping type language like Python, and then interpreted language, and then a more compiled language such as Fortran, and then we'll be jumping to OpenMP, MPI, as well as GPU-based parallelization, and that is, I think, the reason you are here, to learn these skills so that you can develop programs which run faster. I'll also be talking about some software engineering concepts, because your time is also very important. It's not just the computer algorithm that has to be efficient. It's also you who should be efficient. So if you should also learn how to write programs which are easily reproducible, which can be transferred when you transfer the learning to somebody else, as well as your life also is comfortable while you are writing codes or programming algorithms. Okay. So effective computing is a combination of high performance computing as well as software engineering concepts. So we'll be talking about both of these, but our primary focus will be towards high performance computing. And the kind of skills that you'll be learning, they can be applied to desktop computers all the way to supercomputers. So there was a time when parallel codes were only designed for clusters or cluster of computers or even supercomputers. But now, given the architecture you have, because as you know, those who have learned about is no one from electrical, but Moore's law reached some sort of a saturation in terms of the number of transistors we can put on a chip now, okay, because of the heat density problem. So even the laptops that you get nowadays, my laptop has 14 cores in it, so I can run a code which is highly parallelized. And I'm sure your phones also have around 8 cores in them. Okay. So what that means is that the programming in the future is going to be highly focused around parallelization. Although the languages that are being developed are such that it keeps you away from parallelization ideas. You can write codes, they're high level languages, but if you really want to go into high performance computing, then you have to understand what's happening behind the hood. So if you have to drive a racing car, you should know how a car works. If you have to drive a car to commute from north to south campus, then you may just in the hills you should know how the car works anyways. Okay, so it's always good to know what's happening under the hood. So today we'll be talking about some course essentials. I'll be talking about the learning outcomes of this course so that you know what if this course is a suitable course for you. We'll be talking about prerequisites. That's very important because you should definitely have those. Otherwise, you will feel lost very quickly. So software requirements, it's a lab-based course, so we'll make sure you are given everything in the lab. But we'll talk about these requirements in case you want to use or you want to run these problems at home. And I'll also give you a short demo so that you get a flavor as to what sort of key skills you'll be learning or what kind of codes you can develop in this course. Right, so let's start with course essentials. Let's get the course essentials out very quickly. So this course has 2 sessions per week, which means we'll have 4 contact hours per week. So each session will have 2 hours. So you only have 2 classes, but each class will be of 2 hours. So this is LTPC wise, this has 2 lecture credits and 1 practicum credits. So 1 practicum credit becomes a 2 hour per week. So we have 2 hours of practicals and 2 hours of theory per week, so to say. So we have 4 contact hours. So what we will be doing is that we'll have each session 2 hours. So I try to break each session into 1 hour of lecturing and 1 hour of hands-on, either you trying things or I demonstrating things. So that 1 hour of practical will be will include both things. Sometimes it's me who will be doing things, and you can either copy them or you can run them. So feel free to do whatever you want. I'll not question you during the class. Even if you're playing games at the back, I have no problems as long as you don't disturb anyone else. Okay. The venue is A11 PC Lab. So we have 2 teaching supporters, Ravinder and Vishal. So they'll be helping you. They're PhD students who have been here, who have done this course in the last year. So they are used to doing these things on a daily basis. That's their research work. So please feel free to seek help from them. They may not be the experts, but they'll make sure that your problems are sorted. Okay. Um, so things such as installing software, obtaining material, or any announcements, if you could not get that, attendance, all these things, you should consult first with Ravindra or Vishal. If it doesn't work out, then you can talk to me. But feel free to talk to me if you have anything else. But they are going to be your first point of contact for admin purposes in this course. We have a Google chat group for this course. Now this time Moodle is also being used for registrations. So I'm sure everybody has enrolled themselves on Moodle. If you have not, please do that. Now Moodle, if you when you enroll on Moodle, you will have an announcements section on the top. If you click it, I'll put some announcements there. Already 3 announcements are uploaded there. So please keep checking. Usually if I upload something, you should get an email trigger, but do keep checking things in the future. Okay. So there is one announcement which talks about a Google chat group. So this is something I do with all my courses. So you have to use your college ID, because college ID is a Google ID. So you have to use that to enroll in this chat group. The link is given here as well as there. Just click this link, log in through your Google ID, college ID, and you should be able to join that chat. Now that chat is for formal as well as informal discussions. And interestingly, the chat group that we created last year, is still being used by the students to discuss their research issues. So this becomes, some sort of a forum where you can talk to like-minded people. So it's very effective. And since it is you log in through your college ID, so we also have some sort of a moderation where you cannot upload random content. Okay. So please feel free to, but you can only use it till you are a student here. But beyond that, I think you will have enough skills to start exploring the forums beyond this institute. So please learn from your peers. That's very important. Okay? If you try to learn from me only, then there's only enough learning that you can get. But if you try to learn from each other, then the learning becomes even more. I personally feel that learning from peers is sometimes much more effective as compared to learning from the instructor. Okay. So please make use of them. And one of the reasons these institutes are have been doing well for a very long time is not because of the funding it gets from the government and so on. It's because of the smart people that join the institute and they teach each other. So please make it a habit to discuss. Although the grading is relative, but that's a minor part of it. What's more important is that collectively all of you learn well. So try to make use of this forum as much as possible, and don't be shy if you feel that. Feel free to post stuff. Even if you find something interesting on the web about something that we discussed in the class, feel free to upload that on the chat. Okay? I'll also learn from. We also will hopefully we'll have a course mailing list. So I'll put critical announcements there as well. So typically it is me522@courses.itmoney.ac.in. But you do not have to worry for that. I will make sure that we're added to it. But the announcements will be made in the class on the Google Chat group as well as in the course mailing list. I'm sure you'll not miss critical announcements such as submission deadlines for quizzes, assignments, midterms, instants, and so on. All the course slides and materials will be uploaded on Moodle. So all the course slides in PDF format will be uploaded on Moodle by the end of the day the lecture is organized. Lecture recordings, I'll be recording all the lectures for my archival purposes. But in case you missed a class or something, I'll be happy to share that with you. But I don't want to share it with everyone because that tries to hinder you from getting up in the morning. But I'll try to avoid morning classes anyways. But these recordings are only for emergency purposes. Although we'll be recording the complete. So once the course is over, towards the end, I usually, before the exams, I give all the recordings. Okay, now you can revise the complete content through YouTube. But feel free to approach me if you, or approach the TAs if you want the links. All the codes, we'll be writing a lot of codes in this course. So all these codes will be shared on GitHub. So if you don't know about it, GitHub is an online repository where online version control system where you can upload your repositories. So we'll be creating one repository for this course, similar to what we had last year, and we'll be as and when we write codes or generate them, we'll be committing them to the course repository. So you have to keep pulling them. But we'll have one lecture on how to work with GitHub. Books will also be uploaded on Google Drive. So there are too many places, but I cannot upload books on Moodle for copyright purposes. Okay, so books will be uploaded on Google Drive. I'll be sharing a link on Moodle announcements. You can download the books from there. And lastly, we'll have a virtual machine for this course. Many of you may already have logged into the virtual machine. Ravinder, these virtual machines that are there, have you uploaded them recently or are they there from earlier? Okay, so they are virtual machines from earlier. So they may have stuff or they may be modified by the students who were using these. Okay, so in case something does not work as expected, try to download the virtual machine that is available on IT Mandi Cloud and use it. Okay, so these I don't have control over all the machines. People can keep modifying them as and when needed. Okay. But and these seats are not fixed, so you can keep moving around wherever you want. So don't fight with others that this is my spot. Any questions? Right, the most important slide for today's lecture. We have quite a granular evaluation. Now that might seem intimidating at the first place, but it is actually quite helpful in the sense that there's no one evaluation that except the EdSim. You have lots of evaluations, so in case you do not do well for some reason on one, then you have more chances of it. We'll have 15% for objective quizzes. So quizzes are objective. You have to sit here in the lab, open Moodle, click a button. So I will not be testing your programming skills or computer code writing skills, but it's more about how you understand the ideas. I might give you some problems where there is a code and there is an error in one line. So a 5-line snippet of a code, I might ask you what is the error, where is the error. But the questions will be objective in nature for these quizzes. We'll have around, I think, 2 assignments where I'll be testing your programming skills. Now you're welcome to discuss. You have to submit individually. but you're welcome to discuss with friends. In fact, I encourage that so that you learn how to write programs. So the main learning outcome of this is to learn to write computer programs. We have 30% for mid-sem during the mid-sem timings, but since it's a slot-free course, we'll have to do it in the evenings or time dependent on the mutual convenience. So again, mid-sem will be 15 marks out of 30 will be written objective, where you have to log into Moodle, ABCD, do it for some time, and then we ask you to log out or and then go out, come back after 5 minutes, then you start with your lab exam where you have to write a code. Okay, write two parts, so on. Okay. So 15 marks each. And again, code writing, I don't stress people too much during the exam because some people want to take their time to write programs. So I'll be giving you plenty of time to write. Some people might even finish in 15% of the total time given, but that's okay. And I'll try to give you problems which check your fundamentals rather than you writing a complete code that works. Okay, so I try to break code into small parts and then I'll try to ask you to fill some parts in a code and so on. So it will be a very convenient exam as long as you understand you've tried the assignments and so on. NCM 40%, again, same split, 50-50% for written and lab, and we have 5 marks for attendance. Now earlier we used to have 10 marks for attendance, but 80% minimum attendance in all courses. So we have to follow that. That is beyond my control. I'm saying that very clearly this time. So I will not be repeating that towards the end. So please make sure you maintain 80% attendance. Now the TAs will be taking attendance. There will be an Excel sheet available on Google Drive or some Google Sheet that you can check. So the complete class attendance up to date will be there. So you can keep a track of your number of classes you have missed. Or if there's any concern, make sure you highlight that at the next class. Don't come towards the end saying that one day I was present and so on. It creates a lot of inconvenience. I'm sorry we did not have compulsory attendance last year, but this year we have to have it for reasons beyond our control. So make sure you maintain that attendance. 5 marks is still available for attendance because I will appreciate if you attend all the classes or attend lots of classes. Okay, just to encourage positive encouragement, a positive reinforcement. I've given 5 marks for it. Earlier we used to have 10. Now this is a lab-based or demo-based course. Although you'll have all the recordings available towards the end, but you have to understand that retention is better if you sit in the class, especially during lab hours where you try to do things. If you think that you will do it at home, slowly it will get out of hand. The number of hours missed or the time missed will get out of hand. Also, you have to keep trying things at home, but make sure that you do attend classes as many as possible. Any questions? Any concerns? This is the time you have to raise your concerns. Otherwise, we are freezing on this policy. Okay. Right. So let's talk about high performance computing. So HPC, many of you may already know if you're doing research. For those who are here to explore high performance computing, so HPC stands for high performance computing, which often means heavy duty computing. Okay, on either cluster of computers or also supercomputers. Which may have thousands, hundreds of not thousands, hundreds of thousands of cores. Now I'll slowly discuss what these words, cores, flops, and so on, what they mean. But cores is the amount of your phones typically will have 4 or 8 cores. My laptop has 14 cores, some efficiency cores, some performance cores. Okay, so similarly, it's the number of working units that you have in your computer that can work in parallel. So this is the picture of the world's fastest supercomputer. That's based in Tennessee, USA. It's called Frontier. It has 8.7 million cores as compared to 14 cores on my laptop. It has 8.7 million cores, which translates to 1100, approximately 1100 petaflops. Now flops stands for floating point operations per second. So you can think of the number of additions or multiplications the computer can do per second. Okay, so we're talking about petaflop is 10 to the 15, 10 to the power of 15 flops. So it's 10 to the power of 15 floating point operations per second is what this machine can do. Now this is based on some benchmark problem. Okay? And it absorbs 22 megawatts of power. Typically small hydro projects are of this scale. So it's basically, you could think of one small hydroelectric power plant only running this supercomputer. I'm sure something else that's running it, but talking in terms of scales. Now, those who are from Himachal, you may already know the scale of megawatts. If you drive, you'll see this project, so many megawatts, and so on. So the idea is that these are power-hungry systems. I've also put two others. So on number 6, we have Leonardo, that is based in Italy. It has, as compared to Frontier, it's a slightly modest system with 238 petaflops and 7.4 megawatts power that it runs on. And it is, the first one, Frontier, is by HPE Cray. That's the brand, the manufacturer. And then this is by Atos. So it's a company. So different companies make different supercomputers. And the reason I put Leonardo is because the same company, Atos, also has set up a supercomputer at IIT Mandi. So we are one of the very few places in the world that has a supercomputer. Okay. So not all IITs have supercomputers, so to say. So you are in a place which has a supercomputer. And from what I have heard, we are not fully subscribing to it. And one of the major reasons I have heard is because many people do not even know how to use it. Okay, so hopefully through this course, you will be able to learn all the skills, and during the course, you may learn the skills which you can start applying and running your programs on the supercomputer. So please make the full use of it. It's freely available to you, so why not use that as much as possible? Okay, so it's called Param Himalaya. Now, Param is a series name that is given to Indian supercomputers. Okay, so we called it Param Himalaya. What else? And this is 800 teraflops. Okay, so peta is 10 to the 15, tera is 10 to the 12. So it's slower than the Frontier, definitely, but it's still much faster than typical clusters or supercomputers that you see. So 800 teraflops is a lot. It's just not in the top 10 or top hundreds list, but still it is a lot of computing power. And it absorbs 150 kilowatts of power. That's the power requirement for this system. So we'll have 2 lectures dedicated to high performance computing. Although we'll be talking about these in and out, but these 2 lectures, these 2 sessions will be dedicated to HPCs or supercomputers. So if time permits, I'll take you for a visit. But this system is based in South Campus, where the data center is located. Where the Dean DCS office is located. It's a very nice glass building that you have there. That's where the system is. So this was installed only last year. So last year when we taught this course, I think this was not even commissioned. So I was involved with the commissioning, setting up of the system for many years, and we commissioned it last year. We'll also have an optional lecture on data centers, because there's a lot of challenge associated with setting these centers up. You need a lot of transferable skills, such as civil engineering, mechanical engineering, because you need to have heavy machinery stationed there, and the cooling requirements are also very amazing. So you have a dedicated cooling tower that's cooling the system, and it's not the cooling a room, it's basically cooling the processor directly. So we have a fluid which flows past your motherboard, so to say, and that fluid exchanges heat with water through some heat exchangers and so on. So it's a completely liquid cooled system. So we'll have one optional lecture, because I really enjoyed getting involved in commissioning or installing this, setting up the system here. So I hope you'll also be, and in the future, computing is simply, data centers are growing in numbers. Who knows, a few of you may even be involved in setting these systems from the hardware level. Okay. You should know all aspects of it. So we'll have one session on data centers. Right, so let's talk about some computing power. So Gordon Moore, who who was an engineer at Intel, made a prediction in 1960. He said that every 18 months the computing power will double. Now, this prediction is based on statistics, okay? And this was primarily based on not computing power, but the number of transistors electrical engineers or VLSI engineers could put on a chip. So the number of transistors they could put on a chip in a unit area was doubling after every 18 months. Hence, computing power doubling. But then it worked. Okay, and what this means is that within 15 years, you'll have a computing power becoming 1,000 times approximately. That's a lot of improvements. If you write a code and it takes a long time to run, all you have to do is you wait for a couple of years. The hardware will improve and the codes will run much faster. In fact, we have seen these codes that I have when they were run a couple of years ago. They used to take a lot of time as compared to what it takes now on these laptops. Use okay. So there's a lot of improvement that's happened, but very soon we realize that the computing. If you have more transistors, you need more computing power. You need more watts. But thermodynamically speaking, what happens is all the power you give to there's no mechanical work done by these machines. So everything gets dissipated as heat. First law of thermodynamics, right? Heat input, power input is going out as heat. So that heats up the systems. Now, if you put a lot of heat in a small amount of area, it can increase the temperatures a lot, and that can melt your chips. So heat transfer is one of the major bottlenecks that stops us from putting more transistors on unit areas these days. In fact, if you try to overclock your processors, they can sometimes melt, and the computers will have these. Gamers may already know that you can sometimes, if you try to surpass those hard checks, you can actually destroy your machines. Right. Very soon we reached saturation. So beyond that, what's been happening is the number of cores, the number of computing cores you can put on a motherboard has been increasing. You have bigger and bigger motherboards, or you have multiple nodes or blades where you put lots of computers. That's what we do in a supercomputer. So the number of cores available in a machine is increasing with the same factor of the computing power is doubling every 18 months. So Moore's law is still valid. It's a law based on statistics. But the good thing is that the computing power, even if you look at these graphs, where we have the green one, just look at the green one. That's or look at the brown one, the middle one. That denotes the computing power, or the computing performance in teraflops of the world's fastest computer plotted over time. And this is a log graph. So what you see is that a line on a log graph is exponential increase, right? So exponentially, the computing power has been increasing based on the world's fastest supercomputer. Okay. And you can actually have a look at the list of top 500 computers on a website called top500.org. It's a very interesting website. If you enjoy computing, you should definitely browse this website, put it in your bookmarks list. Every, I think, 6 months, they update the list. So this will give you an idea of the top or the most powerful supercomputers of the world and country-wise. And they have a lot of lists based on different sectioning. So our focus is more modest. We'll give you material that is that you can apply on desktops as well as computers, supercomputers. Now, the course is called High Performance Scientific Computing. Okay, the scientific word has been put there for a reason, that we want to discuss computing algorithms which are typically used by scientists. Now, high performance computing can be used in a lot of different ways. For example, for animations. Okay, but we are not going to discuss those algorithms. Although the algorithms we discuss may be used in those animations, but our focus in terms of algorithms will be on scientific computing, such as linear equations, solving a linear system, Ax equal to b. Typically, a lot of problems in engineering or even sciences will boil down to linear system of linear equations, Ax equal to b. Okay, but that's not the only one we'll talk about. Monte Carlo simulations. So we'll be talking about this random number generators and using them to randomize your uh, problem probability ideas will be used there, or differential equations. So molecular dynamics, many people may be doing that. So solving differential equations using supercomputers. So all these ideas are typically used in high performance computing. This time we have also included a lecture on machine learning, because there is no 2024 without machine learning. So we definitely need to have one lecture on that. So we'll be talking about applying, but machine learning typically uses GPU based parallelism for the reasons we'll discuss later. So we'll have two lectures on GPU based parallelism and one follow-up lecture on machine learning, mostly using deep learning, as well as, if time permits, some LLM based ideas as well. Right, so let's now typically each session of 2 hours will be split into 1 hour each. So after 1 hour, I'll give a break. It's very difficult for me to keep talking for 2 hours straight, and for you to concentrate for 2 hours straight. So after 1 hour, we'll have a break of 5 minutes where you can go to the washroom, have some drinks, and so on. Then come back, and then we'll start again. Okay. So we'll have our first break at 5:30. I'll try to finish a bit earlier. So learning outcomes, as I said in the beginning, we'll have two parts. One is on parallel processing, where you learn uh, about computer architecture. Because if you want to parallelize things, you should know how it works inside a computer, in terms of how numbers are stored. We learn how floating point numbers are stored in the computer, some arithmetic, some hierarchy of memory that is there. It's not just computing power, but also the transfer of information that can sometimes become a bottleneck. So it's not just a hard disk or a RAM that is there. We also have a hierarchy of caches, and there's also something called registers available on the processor. So there's a hierarchy of memory. So we'll have to understand that so that we can write codes which are efficient. Although compilers take care of a lot of things for us, optimizations are available where this is kept behind the hood. But as we said, that if you're talking about high performance computing, this territory requires you to understand what's happening behind the hood. Okay, so we'll be talking about these skills. We'll also talk about um, Unix or Linux, because almost all of the clusters and supercomputers are based on Unix-based systems, or a very similar Linux-based system. Even Mac OS is based on a Unix-based system. So we'll be learning. We'll have one lecture. In fact, the next lecture is going to be on Unix and Bash shell. We'll be learning how to write commands and automate things and so on, so that you can write scripts that can automate a lot of work that you do manually on the computer um, through these Bash scripting. So this is a key skill that is required for supercomputing. Any terminal that you log into for a supercomputing or a computing exercise will be mostly Unix-based terminal. Then we'll talk about languages, programming languages. There are typically two types: interpreted and compiled. So interpreted language like MATLAB or Python is something that we'll be talking about. And we'll also talk about Fortran, which is the language of choice. Now, those who are using C, C++, or Java, there's no problem, because the ideas that we'll be discussing are very straightforward. In fact, I am teaching through Fortran is because I have been used to Fortran. I've been using Fortran for my scientific computing codes for research in the past. But so I'll be teaching you Fortran, just two sessions on that, and then we'll move on to the parallelization ideas. But what you'll realize is that I'll also show you how to parallelize a C code or C++ code using those ideas towards the end of the session. And you will see that it's very similar. So as long as you know programming, you should not have any problem in understanding. In fact, you should be versatile in terms of choice of languages. Who knows which company or which code you work with in the future. So as long as you're comfortable adapting to new languages, that's the best thing if you want to stay in computing, because computing evolves very quickly. Okay, so we'll be using Fortran 90 for writing our heavy duty codes. Parallelization will be done using OpenMP. So I'll be talking about OpenMP, MPI, and OpenACC. I'll talk a bit about these things in detail. And we'll also have a session on cloud computing. So nowadays, not everybody is lucky to have a supercomputer in their campus. But that should not stop you from writing high performance codes. All you have to do is you have to buy some compute time, which typically is billed by the second from some cloud computing service. In fact, our supercomputer, as far as I am aware, is actually renting compute time to people outside. Okay, so we'll be talking about cloud computing. So typically we discuss Amazon Web Services. Okay, so Amazon had bought a lot of storage space and computing power for their personal purposes, but later they realized that the computing hardware it gets outdated very quickly. So rather than keeping that, why not rent computing? So some time ago, computing became a service rather than something you had to buy. So nowadays, if you want to high performance computing, you will not buy a very heavy duty computer. It's a waste of money because if you cannot use it 24/7, then you are wasting because after a few years that will be outdated. Okay, so we'll learn how to um, write. So once we have learned how to write these heavy duty codes, we learn how to use Amazon Web Services, for example, for running our code. It's very interesting because you'll be able to develop an machine image on their website, on their terminal, log into terminal for that, and then run a code. And you can even decide, I think, when the code runs, because depending on the requirement, the prices fluctuate. So you can set up a, I mean, if it's not critical, you can say that whenever the prices are below this, you just run the code, and as long as your code is running, you'll be billed through a credit card. So I'm not sure everybody can enroll into that because you have to be careful. If you make a mistake, you might get a huge bill. um, so I'll show you using my credit card, but I'll not give you the credentials anyways. So we learn how to use cloud computing. It's very interesting because if you're traveling and you want, and it's not very expensive. So if you want to travel and do these things, you can easily do them. You don't have to carry heavy laptops with you. And the codes will be running, the results will be getting generated as well as you have learned Unix, scripting, Python scripting. You can write very efficient scripts which will run lots of codes. Lots of data will be generated. It will be plotting things on graphs. The graphs will be plotted into a file. The file will be emailed to you, and all you will get is an email with an image that is a result of many days of many months of computing. So this is something you can do, and rather than logging in and doing this, you can automate that. Even I will show you how to upload automatically images on a. It will just upload an image on my web page, and I can refresh the web page and see the latest. So that way you can share the research with the supervisor, and your supervisor might think that you are doing lots of work, but you might just be writing a script and then holidaying somewhere in Kosovo. Who knows? Okay. Then efficient programming practices. So we'll be talking about Python. Now Python is very human friendly. So if you want to write plus plus or Fortran, if you do that, then you are a pro. But most people will start writing in Python if you have a new algorithm you want to try, because Python is very good for prototyping. You can just it's interpreted. You write a line, press enter, it gives you the result. It may be slow, but that's okay. I mean, you will test these algorithms for smaller scales. And then once it works, you're happy with that, then you can scale it up. So typically prototyping is done on MATLAB or Python. So we'll be using Python for that because MATLAB is paid, and our rule is we only work with free software. We only pay for computing power, not for software. It's not that paid software is not good. The only thing is that as in a class like this, I don't want to promote a given commercial software. Because Python you can easily install on any machine, but for MATLAB you have to get the software, you have to get a license, and beyond this institute you may not even have access to MATLAB, which is free. It's very expensive. Okay, so we'll be using Python for scripting, and Python you can also do scripting, so it can interact with your hardware very well as well. So if you want to run lots of Fortran codes, personally I sometimes use Python scripts rather than using a bash script. I would use a Python, so I'll call a Python code, and that Python code will call lots of Fortran codes by making minor modifications in my code and submitting the file. So you can write very interesting scripts with Python as well. And Python is heavily collaborated throughout the world. You get a new version almost every few weeks. We also talk about version control. So when you write codes, it's very important, not just collaboratively, even if you write by yourself, because you are also a function of time. So you might write something, then you realize it's not working, you might delete it, but then you realize, oh no, it was good, but then you deleted that. So you should have some sort of versioning where you have a complete history of what you're doing. So that is typically done in coding through something called GitHub, through something called Git. Git is a version control system. We also have other VNCs, but typically we use Git, which is almost like a standard now. Personally, when I was doing my PhD, I was using Git for even writing my thesis, because it's simply version control. It doesn't care if you have a code or you have a LaTeX file or you have something else. As long as you have something which is text based, so what it does is it maintains different versions. So if I write a line, I commit to it, then I can go to my home, to my laptop, and then pull the changes and start working on that. So it has a complete history of everything. It's something like, Google Docs. So Google Docs, whatever you do, it has a complete history. So it's that for a complete project which has lots of files, and then you can put it on repository or repository management systems like GitHub or Bitbucket. You can share with people. People can collaborate. They can fork their projects. They can improve them. They can do something else and so on. So it's very versatile, and you should definitely know about GitHub or Git if you are doing anything to do with programming. We'll talk about Makefiles. So Makefiles is a build system. Now, those who have tried to install or who have installed software on a cluster or their Unix-based machine in the past, you may see instructions like you download the code through Git, do a /configure, then you do a / or you do a make install or a make, and then you do a make install in that house. And typically, if you do this, somewhere you'll get an error. So what is this make? Okay, this is a build system. So we'll be learning this. It's actually a language. So we'll be having one lecture on that because it's very important for you to learn about make. It also does a lot of dependency checking for you. So if you have a code which has hundreds of, if you have software which has hundreds of programs in it, hundreds of code files in it, and I make change to one file, I don't want to compile the whole project again, because compiling takes time. If you use optimization, it takes even longer. Okay. So rather than compiling everything, this dependency checking will make sure that it will only compile things which are dependent on that change that you have done, that onwards. So we learn how to write make files and also how to use them in this course. Debuggers, we learn about debuggers a bit so that we can debug our codes if we get stuck with some error. We talk about code testing. It's also very important to develop tests, because when the software grows beyond a couple of people, then there have to be some tests in place, so that when you contribute something in the future, the previous settings or previous features should not stop working. So there is something called a test harness that is maintained, so that every time a change is made, a build bot will run all the tests and make sure they pass. So we learn about these ideas of developing tests in programming and how to automate running tests and so on. And as I said, we'll also talk about high performance computing clusters. Questions? There's a lot of stuff in the course. Well, it has to be, because it's a full semester, of course. So what is the strategy to learn all these things? Well, there's a lot of material, as I said, and we have only enough time. Although we have the full semester with us, but we have only 2 hours per session. So I'll not concentrate on everything, because I can have one full course and even that will not do justice to, let's say, Fortran. But the idea is not to make you an expert in everything in this course. The idea is to get you started through some motivating examples. And once you get started, once you're confident, then you can learn easily. But you have to have that initial start where you understand. If you seek help on the internet, or you try to open a manual for that software or for that programming language, then you should be able to understand what it means and what those features are. Okay, so we'll make sure that you get some sort of level of expertise in all these things, so that you are happy to grow beyond that. But rarely you would be using just these things in your research. You will be needing a lot more. But if for job interviews, for example, if you sit there, then you won't be expected. Nobody will be asking things beyond this course, because then it gets very, very sophisticated, which typically is demonstrated not through interviews but through work. And we'll be giving a lot of hands-on experience. It's not just slides that are important. In some lectures will only have 2 or 3 slides. Mostly I'll be doing things here, and you will be following that, or you will be trying to understand that, and I'll already upload the full code in front of you so that you can keep looking, and I'll be talking through writing commands here. Even though I might have a complete code available beforehand that might be shared with you, but I'll write the code from scratch in some cases, so that you can stay with me, because it can sometimes get too complicated for you to absorb everything very quickly. So we'll try to go slow, but do give that feedback. So we'll have feedback sessions every month. So I'll ask you your feedback, but feel free to give your feedback before that as well. That's pretty much it. There's no reference book as such. If you try to look for high performance scientific computing, I don't think you'll get any book. Well, I haven't found. Even if there are books, they're basically books on OpenMP or MPI, one of these things, okay, or both. So that is because this is not a classical subject taught in a classroom. This is it's a skill that you have to learn through experience. Now, earlier, when I was doing my research, when I was a student, there were not even courses like this. Now people have started to develop courses like high performance scientific computing, because clusters are available a lot more in number. But earlier it was based on somebody passing their skills to their students or their juniors and so on, and the skill used to remain in a close. So if you have worked with IBM, you know these skills. But if you have worked with a startup and you have no experience with big companies, then you will not even know what programming languages are used on supercomputers. Okay, but there are reference books on and off. So I'll share these books with you on Google Drive that you can download and refer to. But most of these skills are updated so frequently that those books also will be written a couple of years ago, and they are old versions, and you have new options available and so on. Even Python, for example, when these like slides were developed, it was Python 2. Now we have Python 3, and even 3 has minor modifications. So we had to rewrite many Python codes just to stay up to date. Okay. So let's have a break for exact 5 minutes, and then we'll continue with this session. If you have any questions or queries, you can come up and we can talk.